day to everyone. My name is K S Mathew, Professor in the Department of Computer Science, Rajagiri School of Engineering and Technology, Kochi. Today in this session, I am going to discuss one of the topics in Module 6 of course CS308 Software Engineering and Project Management. The topic I am going to discuss is project scheduling and tracking, which comes under project management. So in any project, as part of your planning, project planning, you need to develop a schedule for your project, which includes all the activities which you need to do and decide the time frame during which you will be doing different activities. And activities are not independent, they are all, some of the activities will be related. So you should also decide the sequence in which the activities have to be carried out, and also the duration and the responsible person for doing each and every activity has to be set as part of your scheduling. And once you prepare your schedule, you can start monitoring or tracking the schedule in order to understand how the project is progressing and what is the progress of the project in terms of percentage completed, etc. And you can also see whether there is a delay in the project, or whether the project is going as per the schedule, or is there a slippage in the schedule. So that is what is done as part of project scheduling and tracking, which is a very important process as part of project management. The primary goal is to ensure that the project is completed on time without any slippage. So these are the various subtopics we are going to discuss as part of this session. WBS is nothing but work breakdown structure, which I will explain what it means. Activity planning, activity sequencing and network diagram, activity duration estimation, network analysis and identifying the critical path, assigning resources to various activities. Finally, how to develop a schedule, and we will see the Gantt chart, which is the most popular view of a schedule. And then we will look at how do we track the schedule or monitor the schedule once the schedule is prepared and finalized. The basic input needed for developing a schedule, preparing a schedule is WBS, work breakdown structure. Work breakdown structure is a subdivision of major project deliverables into small sub-deliverables and sub-deliverables. So as part of your project, even in the beginning stages itself, we will be able to identify what are the major deliverables of the project, which will be normally documented as part of your project initiation document or the project charter. And there we will list out what are the major deliverables in this project in different phases. In every phase there will be a major deliverable. For example, in the requirement analysis phase, we will get a major deliverable called SRS, Software Requirement Specification. Then we will move on to design phase. We will have another major deliverable called design document. So there are different major deliverables in every project. So these major deliverables have to be broken down into sub-deliverables, smaller sub-deliverables, so that we can estimate the time required for doing developing or producing that sub-deliverable. We can assign responsibility for that activity. All this can be done when we subdivide the major deliverables into small sub-deliverables. If the deliverable is a big chunk of work, we will not be able to estimate it accurately, and it is also not possible to assign the entire responsibility for that big module to one individual. Whereas if you broken down those that big deliverables into small sub-deliverables, the estimation becomes more accurate, and we can also assign responsibility for that individual single sub-deliverable to a person, individual. So that is the purpose of dividing the major deliverables into sub-deliverables, and finally you will get something like a tree structure. On top root node you have the project, the major deliverable, entire project, which can be further divided into main sub deliverables. Then under each main sub deliverable you can have further sub deliverables, components, right? So you will get a tree structure that is called WBS. So what is the purpose of dividing major deliverable into small, more manageable components? It will improve the accuracy of estimation, cost estimation, duration estimation, and resource estimates, and it helps in defining baselines for performance measurement and control. For example, if you want to monitor the schedule performance of a project to see whether the project activities are getting completed on schedule, you need to divide the major deliverables into smaller deliverables. Then the estimation of that time required for completing that sub deliverable can be estimated more accurately once you divide. And once you set a duration for completing a sub deliverable, when you actually do the activities for producing that sub deliverable, we can compare the estimated duration with the actual duration and see whether it is going as per the schedule or there is a slippage in that activity. So it becomes a baseline for measuring your performance. Third reason why we need to have a breakdown, work breakdown structure, is facilitate clear responsibility assignments. As I said, if it is a big module, assigning responsibility for that big module to an individual or a group of individuals may not be very easy, and monitoring the progress also will be difficult. But if you divide a big deliverable into small sub deliverables, responsibility can be easily assigned to few individual people, and this WBS becomes the basis or basic input for preparing a schedule. Next step in schedule development is activity planning. So in the WBS we have decomposed the major deliverables into sub deliverables. So the next activity is to identify and document what are the activities to be carried out in order to produce each and every sub deliverable in the WBS. That is what is done in activity planning. For each sub deliverable or sub deliverable, what are the activities to be carried out in order to produce that sub deliverable? That is what is done in activity planning. So when you complete activity planning, you will get a list of activities to be carried out in order to produce various deliverables of a project. And you could also have a list of milestones as part of activity planning. When you complete a set of activities, you will reach a milestone. So you can also indicate some milestones in every phase. Once you complete a set of activities, it will reach a milestone. For example, once you complete the writing or preparation of SRS and review of SRS, so there are a lot of activities to be done for preparing and review of SRS. Once you complete all those activities, you can sign off the SRS. So sign off of SRS can be treated as a milestone, which is a major milestone of your project. So which will be after preparing the SRS as well as reviewing the SRS. Similarly, design completion, coding completion, testing completion, release of the first version, all these can be treated as major milestones in a project. So once you complete activity planning, you get a list of activities and a list of milestones. The next major activity is activity sequencing. So activities are not independent. All the activities are not independent. Some of the activities will be dependent on another activity. Output from one activity may be needed to start another activity. So the activities will be related with each other. Output for an activity may go as an input for another activity. So unless you complete the other activity and have the output ready, you will not be able to start another activity. So activities will be related with each other. It need not be always independent. So the next step in scheduling is to identify and document the interactivity relationship or logical relationship between different activities. The common technique used for showing the sequence of activities is network diagram. So different network diagrams are used to represent the relationship between various activities. Primarily, there are two types of diagramming techniques: precedence diagramming method, or PDM, or activity on node, and the second technique is called arrow diagramming method, or activity on arrow, or CPM. ADM, AOA, CPM, and PDM, or activity on node, AON. We'll see how this network diagrams look like. So this is an example of the precedence diagramming method network diagram based on precedence diagramming method, where it is also called activity on node. So the activities are represented using nodes in the network diagram. The arrows between the nodes indicate the transition between one activity to the other activity. The relationship between activities are represented using arrows, and activities are represented using nodes. So that is what is done in precedence diagramming method, or activity on node network diagram. So here, as you can see from this network diagram, start and finish indicate the project start and project finish. There are 6 activities: A, B, C, D, E, F, and activity A is independent, which can be started. There is no dependency for activity A. So the activity can be started, activity A can be started as soon as you start the project. Similarly, activity D is also independent. It doesn't have any dependency with any other activity. So activity D can also be started as soon as you start your project. But activity B depends on A. So the activity B can be started only after A is complete. And activity E depends on D. So activity E can be started only after completing D. Now, if you look at C, you can see activity C depends on B as well as D. So activity C requires output from activity B as well as output from activity D. So activity C depends on B and D, which is represented by connecting arrows from B to C and D to C. So that is how the relationship between activities are shown in PDM. Activity F depends on E, so which is represented using the arrows connecting E and F. When you complete all the activities A, B, C, and D, E, F, C, and when you complete activity C and F, the project is completed. So that's how the PDM network diagram looks like. So this way we represent, identify, and document the relationship between logical relationship between various activities. Second techniques for representing sequencing activity relationship is arrow diagramming method. Here it is also called activity on arrow. So the activities are represented using arrow in this type of network diagram, and the nodes represents events. Nodes represent the events or completion of a set of activities represented using nodes in the network diagram. Activities are represented using arrows. And this activity arrow diagram method, arrow diagram method or activity on arrow diagram is same as the other one, activity on node, which we have seen with 6 activities A, B, C, D, E, F. So here C depends on B and D, as we discussed in the previous diagram, so which can be represented using a dotted line like this. So in the case of arrow diagramming method, in order to show the relationship, sometimes we need something called a dummy activity, which is represented using dotted arrow. So in order to represent the relationship of C with B and D, you can represent the relationship between B and C using a solid arrow, but C also depends on D, which can be represented only using a dummy activity here. Dummy activity which is represented using a dotted arrow. So dummy activities are required only in only in arrow diagramming method. PDM doesn't require a dummy activity. Dummy activity doesn't have any duration, but the normal activity will have a duration. And there are different type of relationship between tasks. There are 4 types of relationship between tasks which can be represented uh, like this. So there is a relationship finish to start, that is the normal relationship between the common relationship between two tasks is finish to start. That means a task B can be started only after completing task A, and task A is called as predecessor of B, and task B is the successor of A. So arrow connecting A and B is this is the finish to start relationship. A is known as predecessor of B and B is the successor of A. The second type of relationship is start to finish. So B, which indicates B can be completed only when A starts. So B can continue, but B will get completed only when A starts. So A is the predecessor and B is the successor. B will get completed only when A starts. There is third type of relationship, finish to finish. So B will get completed only when A also completes, only after A completes. So B and both A and B will continue, but B will get completed only when A also completes, which is called finish to finish. Fourth type of relationship is start to start. So in this case, B starts only after A starts. A and B B can be started only after A starts. Unless A starts, B cannot start. That is start to start relationship. So if you look at a normal project, construction project for example, you can construct the brickwork, start the brickwork only after completing the foundation. So the building the foundation and brickwork, there is a finish to start relationship. Brickwork can be started only after completing the foundation. So it's a finish to start relationship. Now there is something called lead and lag in the task relationship. So in this example, A and B has a finish to start relationship. That means B can be started only after A is complete, but not immediate, after a lag of 2 days, which is represented using using the relation in the, you will put the duration of the lag in the arrow connecting A and B, so which is called lag. For example, in a construction project, you are building your house. The first floor brickwork, you can start the first floor brickwork only after completing the concreting of ground floor. That's the normal relationship. So A could be the concreting of ground floor, B is the brickwork of first floor, so which has a finish to start relationship. But after completing the concreting of ground floor, you cannot immediately start the brickwork of first floor. You need to give some time for curing the concrete. For example, 1 week time or 10 days time to get the concrete cured before you can start the brickwork of first floor, which can be represented using a lag. So there is a finish to start relationship, but the second activity can be started only after a delay of 2 days or 7 days or 10 days, in the case of construction project. That is called lag. Similarly, there could be a lead also. Some of the activities could have a relationship finish to start. So activity B can be started only when A is complete, but in a particular case, there may be a situation where B can be started 2 days in advance of A's completion. So A and B has a finish start relationship. So unless A is completed, you cannot start B, but we can start 2 days ahead of completion of B, which is represented using a lead. So in project management tools or scheduling tools, there are options for all these type of relationship and for setting lag and lead. Now we look at we'll discuss another important concept in project scheduling called critical path. Consider the previous network diagram. So here I am taking the activity on arrow network diagram. So we have 6 activities A, B, C, D, E, F, and the relationship between these activities are represented using this arrow activity on arrow network diagram. So in this network diagram, from start to finish, how many parallel paths are there in this network diagram? How many parallel paths you can identify or find between start and finish of this network diagram? So we can see there are 3 parallel paths. One parallel path is A, B, C, and the second parallel path could be D, E, F, and there is a third parallel path D and C. So let us calculate the duration of these parallel paths. A, B, C is 10 plus 8 plus 7, 25 days. D, E, F is 7 plus 12 plus 12, 31 days, and D, C is 7 plus 7, 14 days. And what is the minimum time required for completing this project? What is the minimum time required for completing this project? This project will be completed only when you complete all 6 activities, right? And DEF can be done only sequentially. So you cannot start E unless P is complete. You cannot start F unless E is complete. So DEF can be completed only sequentially. Similarly, ABC also can be completed only sequentially. So the minimum time for completing this project is the longest duration of these parallel paths. Parallel paths indicate those activities can be done only sequentially. So the longest duration of these 3 parallel paths is 31 days, which is DEF. So DEF will get completed only after 31 days because they have to be done sequentially. So the minimum time for you to complete the project is the longest path duration, which is 31 days, and that path is called critical path of your project. So critical path is the longest path through the network diagram from start to finish, and it is the shortest minimum possible completion time for the overall project. So you need minimum 31 days to complete the project, and that's the duration of the longest path between start and finish, and that is called critical path of a project. But in a project, in a real project, in this case there are only 6 activities, and network diagram is very simple. But in the case of a real project, there could be hundreds of activities, and the network diagram will be very, very complex with 100 activities. So you will not be even able to identify all the parallel paths. It will be very difficult to identify even the parallel paths. Then again calculate the duration of all the independent parallel paths, and then look at which is the longest path and decide the critical path. That is not really practical in the real project environment. So how do we go about identifying critical path? There is a structured way to identify the critical path, which is called network analysis. So in the network analysis, there are 2 phases. One is called forward pass, and the second phase is called backward pass. In the forward pass, you will start from the start node and traverse through all the activities till you reach the finish node, and calculate 2 values for each activities: early start and early finish. So in the forward pass, you will start from the start node and traverse through all the activities till you reach the finish node, and during this phase you will calculate 2 values for each activity, which are early start date of an activity and early finish of that activity. Then you will do the second phase, which is called backward pass, where you will start from the finish node and traverse backwards till you reach the start node, and during this phase you will calculate 2 values for each activity, which are latest start and latest finish of each activity, LS and LF. So once you complete the forward pass and backward pass, you will have 4 values for each activity: early start, early finish, and late start and late finish. Then you will calculate a third value for each activity, which is called total fruit, which is the difference between late start and early start, or late finish and early finish. It is called total float. Total float means it tells how long an activity can be delayed without delaying the project completion. So total float, you can calculate the total float for each activity: late start minus early start, or late finish minus early finish. And critical path is the path joining all the activities with zero float. So once you calculate float, some of the activity will have a float greater than 0, some of the activity will have a float of 0. So the critical path is the path joining all the activities with 0 float. So float indicates that float of an activity indicates how long that activity can be delayed without delaying the project end date. So if an activity is having 0 float, that indicates that the activity cannot be slipped even for a single day. If it slips by single day, the project end date will also slip. Whereas if an activity is having a float of say 3 days, that indicates even if that activity gets slipped by 3 days, the project end date will not get slipped. Project end date will remain same as we decided in the beginning. But if an activity is having a total float of 0, if that activity gets slipped even by 1 day, the project end date will also slip by 1 day. Now there is another concept called free float of an activity, which is the difference between early start for the next activity minus early finish for the current activity. Free float of I will be early start of j minus early finish of I. So this free float indicates how long an activity can be delayed without delaying the next immediate activity. That is what is called free float. Total float and free float will be different or same in some cases. But total float is what is more important, because it tells how long an activity can be delayed without delaying the project end date. Free float tells how long an activity can be delayed without delaying the next immediate activity or the successor of that activity. And critical path is the path consisting of activities with 0 total float. Let us look at an example for network analysis. So this is a network diagram, activity on node network diagram, where there are 8 activities: A, B, C, D, E, F, G and H. So these are the 8 activities. So let us do the forward pass first. So assume that the project starts at time 0. So the early start of task A will be 0. Early start of task A will be 0, and duration of task is 7. So the early finish of task A is 7, and task C depends on task A. So the early start of C will be 7, and duration of C is 6. So the early finish of C is 13, and task G depends on C. So the early start of ES will be equal to the early finish of C, that is 13, and task G duration is 3. So the early finish of G is 16. Now let us look at task B. Early start task B doesn't depend on any other activity, so it can be started as soon as your project starts. So project start is considered as 0. So early start of B is 0, and duration of B is 3. So early finish of B is 3, and task D, early start of task D is 3, and duration of D is 3. So early finish of D is 6. Early start of task F depends on B. Task F can be started only after B is complete. So early start of F is equal to the early finish of P, which is 3, and duration of F is 2. So the early finish of F is 5. Now let us look at task E. Task E depends on both task D and F. So task E can be started only after completing both task D and F. Early finish of task D is F. Task D is 6, and early finish of task F is 5. So what would be the early start of task E? Task E can be started only after D and E are complete. So the early start of E will be the highest of early finish of D and F. So even though task F completes on 5th day, you cannot start E on 5th day because task E is not complete on 5th day. Task E will be complete only on 6th day. So task E has to wait till D is complete. So the early start of E will be 6 and the duration of E is 3. So the early finish of task E is 9. Now let us look at task H. Task H depends on both task E and E. So task H has to wait till task E and E is complete. So the early start of task H will be the highest of early finish of task E and task E, which is 16. So the task E is complete on 9th, but we cannot start H on 9th day because task E will be complete only on 16th day. So task H has to wait till G is also complete, which is on 16th day. So the early start of H will be 16 and duration of H is 2. So the early finish of H is 18, 16 plus 2. So we have completed forward pass. Now let us do the backward pass. So in the backward pass, you start from the finish node and traverse backwards through all the activities and compute date start and date finish of all activities. So our aim is to complete the project as early as possible. So we will assume the late finish also as the early finish. So late finish also as the early finish. So 18, we will start with late finish of task H as 18. So our aim is to complete as early as possible. So we take early finish date as the late finish also, the 18, and traverse backwards. So duration of H is 2, so the late start of H is 16. So late start of E will be 16 and duration of E is 3. So the late start of E is 16 minus 3, 13. And late finish of F will be 13 and late finish of D is also 13, which is the late start of task D. Now duration of D is 3, so 13 minus 3, 10 is the late start of D, and duration of F is 2, so 13 minus 2, 11 is the late start of F. Now let us look at task B. So late start of task B is 10, late start of task F is 11. So late start of task B is 10. That means task B cannot be delayed more than the date 10th day. Late start of D is 10 and late start of task F can wait till 11th day to start, but task D cannot wait more than 10 days. So the late finish of task D and F depends on task B. So the late finish of task B should be the lowest of these two late start dates of D and F, which is 10. So the late finish of B will be 10, which is the lowest of late start of D and late start of F. And duration of B is 3, so 10 minus 3, 7 is the late start of B. Now if you go this way, task H late start is 16, so the task G late finish will be 16. Duration of G is 3, so 16 minus 3, 13 is the late start of G. And late finish of F, late finish of C will be 13, which is the late start of G. Duration of C is 6, so 13 minus 6, 7 is the late start of C. And late finish of A will be the late start of C, which is 7, and duration of A is 7, so 7 minus 7, 0 is the late start of A. So we have completed both forward pass and the backward pass. Now you can calculate the total float for each activity, which is the difference between early start and late start, or difference between early finish and late finish. So here we can see the total float of A is 0, which is the difference between early start and late start, or early finish and late finish. And task E total float is 0, and task G total float is 0 and task H is total float is 0, and task B total float is 7 minus 0 7 or 10 minus 3 7, and task B total float is 7, task F total float is 8, and task E total float is 7. So critical path is the path joining all the activities with 0 float. So in this case, in this example, A, C, G, H, A, C, G, H, task A, C, G and H are the activities coming on the critical path which has a float of 0. So all the activities with 0 float, path joining all the activities with 0 float is the critical path of this project. So free float, we will also see what is the free float of some of the activities in this network diagram. So the total float of task B is 7. Total float of task B is 7. But let us look at what is the free float of task B. Free float of task B is the early start of the successor, which is D. Early start of the successor, which is D, that is 3, and early finish of the current activity B, which is 3. So 3 minus 3 is 0. So the free float of task B is 0, which is the early start of the next activity minus early finish of the current activity. 3 minus 3 is 0. 0 is the free float of task B. Total float of B is 7. That means task B can be delayed up to 7 days. Even then, project will not get slipped. Project end date will not get slipped. Project will be still completed on 18th day. But if task B gets slipped even by free float is 0, that means even a 1 day slippage in task B will result in delay of task B, but it will not affect the end date of the project. So free float is the duration by which an activity can be delayed without delaying the next immediate activity. So zero free float indicates that this activity, if it gets slipped, the immediate activity will get slipped, but it doesn't mean that it will affect the end date. End date depends on the total float, which is 7 in this case of task B. So task B, even if it gets slipped by 7 days, the end date will not get slipped. End date will be still 18. But task B, if it slipped by 8 days, then the end date will get slipped by 1 day. So there are some rules for constructing CPM network, activity on arrow network. Project network may have only one start node. Project network will only have one start node and one end node. The definition of project says a project is a temporary activity. It will have a definite beginning and a definite end. So that indicates there will be only one start node and one end node for every project network diagram. A link has a duration and nodes have no duration. Time moves from left to right. Nodes are numbered sequentially. A network may not contain loops. Time always progresses forward positively, right? So time will not go back. So network will not contain any loops. If you see an arrow going backwards, that's an indication that the network contains a loop. Or if you look at the number of nodes at the tail of an arrow and the head of an arrow, the number at the head will be greater than the number at the tail end of the arrow. If the number at the tail end is higher than the number at the head of the arrow, that indicates there is a loop in the network diagram, which is not allowed. Network may not contain dangles. The network diagram will not have any hanging nodes. Hanging nodes are nodes which is having only arrows in one direction. So except the start node and the end node, start node will have only arrows going out and the end node will have only arrows going in, all other nodes in the network diagram will have both arrows going in and going out. So other than the start and the end node, there will not be any hanging node which is having only arrows in one direction. This is another example which you can look at. And network analysis, another example. This is the third example of network analysis which you can see. And if you look at the scheduling software, there are a lot of scheduling project management software for scheduling the project. MS Project is one of the popular projects. MS Project is one of the popular scheduling software from Microsoft. And there are different views in MS Project. One of the view is network diagram view, the MS Project. If you look at the network diagram view, you will see the network diagram like this, which is an activity on node network diagram or precedence diagramming method. All the software, project scheduling software, project management software commonly use PDM network diagram or activity on node, which will look like this. So activities are represented using the nodes in the network diagram. And in the node you can see various attributes of the activity. There is an ID for the activity, there is a start and the finish date of the activity, duration of the activity, resource assigned for that activity. All this will come as different attributes of the activity, which is shown in the node. The arrows represent the relationship between the activities. So this is a network diagram view of MS Project. So even once you have the activity list, you have prepared the network diagram in the previous examples, but and calculated the critical path. But that is for you to understand what is the critical path, how to identify the critical path. But when you use a project scheduling software like MS Project, all this forward pass and the backward pass and identifying the critical path is all done automatically for you by the scheduling software. You don't have to do it manually. Calculate the early start, early finish, late start and late finish, and calculate the float, then identify the critical path. All this will be done automatically for you as you schedule the activities and link the activities and put the duration for these activities. They will automatically calculate, do the forward pass and the backward pass and calculate float, and then identify the critical path for you, which will be indicated in red color in the network diagram view. If you look at the network diagram view, the activities that comes in the critical path will be shown in red color. The next activity in scheduling is resource allocation. So we have identified the activities, we have sequenced the activity, we have decided the sequence in which the activities have to be carried out. We have calculated the duration for the activities. Then now you need to assign the responsibility for carrying out various activities in the project. So based on your activity team list, you have a resource list as part of your project. You might have identified the resources who are going to work in the project. You have the team in place. Now you can assign responsibility for various activities to individual members of the team. And as we discussed in the activity duration estimation, the duration will vary based on the resources you are going to assign. So when you calculate the duration, you should have some understanding on the resources you are going to assign for that activity and the number of resources you are going to assign for that activity. Based on that, you have estimated the duration. So you will assign that type of resources and the number of resources for each activity and assign the responsibility. This also can be set or assigned in the scheduling software like MS Project or Primavera. And once you do this, you will be able to see another common view in the scheduling software called Gantt chart view, which is the commonly used view for schedule. So which is like a bar chart, horizontal bar chart, and this Gantt chart has two panes, two parts. On the left hand side you have the activity list with the duration of the activity, name of the activity, the ID of the activity, name of the activity, duration of the activity, start date of the activity, and the end date of the activity. That is on the left hand side, which is the activity pane, and on the right hand side you have the taskbar. You have the taskbar. Corresponding to each activity, you will see a bar indicating which is the start date and end date of that activity. And the assigned resource will also be shown as a caption on the right side of the bar. So this view is called Gantt chart view. And also the relationship between the activities are shown using arrow connecting these bars on the right hand side. So you can see the activity detailed requirement analysis and the SRS preparation, they are connected. So the SRS preparation can be started only after detailed requirement analysis. So which is a sequential activity, which is represented using the finish to start relationship. The task relationship can be easily changed in the project schedule MS project by clicking on this arrow. When by default the relationship is finish to start. So when you link two activities, the automatically it takes the relationship as finish to start. But if you want to change the relationship, double click on this arrow and you will get a small pop-up, and where you can change the relationship to finish to finish or start to finish or start to start. So this is the default view in the project scheduling software called Gantt chart view, which helps you to show the progress of the activity or the assignments of the activities and relationship between the activities. Now, after assigning the resources, before finalizing the schedule, you need to do another activity called resource labeling. Suppose you have 10 members in the team. So it is not right, it is not fair to load few of the resources 8 hours a day or 9 hours a day or 10 hours a day, and load some of the resources with only 2 hours of work in a day. So when you assign work for various resources, all the members of your team, you need to ensure that all the team members are uniformly allocated with 8 hours of work in a day. It is not fair to allocate 2 hours of work for one person and 8 hours of work for another person in the team. So after scheduling and assigning the responsibility for various activities to resources, you need to ensure that the resources are uniformly loaded with work. This can be seen by going to another view in the project scheduling software called resource usage view. So when you go to the resource usage view, it will show what's the allocation of work for each resource on a daily basis. You choose the resource and it will show you what is the percentage of allocation for each resource, for that resource. And if a particular resource is over allocated on a particular day, that will be shown in red color. So in this example, you can see the resource Vijay is over allocated on one day, on one particular day, right? It is shown in this red color. So it will not work. So a person can work only for 8 hours in a day. If you are saying work for more than 8 hours for a person, that will not get completed. So there is a problem. So this over allocation has to be removed before you finalize your schedule. So that activity is called resource labeling. So there are different options for resource labeling. One of the options is the manual. So how do we over allocate, or how do we remove this over allocation? How do we remove this over allocation? So this over allocation normally happens because on this particular day you might have assigned another activity also for this person. You have assigned 2 activities for this person on this particular day. That could be one of the reasons for this over allocation. So instead of allocating both these activities to the same person, One of the options could be you see whether you can assign the second activity to another person who is not loaded 8 hours on that particular day. Right? That way you can remove this over allocation. Another way is to see whether there is a float for these activities. You have assigned 2 activities for the same person and see what is the float available for these activities, and you find that there is a float available for the second activity. That means that activity can be delayed by the float available. Still the end date will not get slipped, but the over allocation will go. Right? So you use the float to delay an activity so that over allocation can be avoided. Another way is to distribute the effort on a day to both activities. So you tell you can 50% of your effort, 50% of that resource effort can be spent on task 1 and 50% can be spent on the second activity. So you will assign only 4 hours on that day to task 1 and 4 hours for the second activity. That way the total allocation can be reduced to 8 hours. So the allocation will be removed. And this is the manual way of doing. And then in Microsoft Project there are 2 options. Again, it is automatic and manual. By default it is manual in MS Project. So what it does is, so in that manual option there is a button called level resources. So when you use that option, level resources, Microsoft Project will look at the priority of the activities and it will look at the float available, etc., and do some based on some heuristics, thumb rules, it will remove the over allocation and ensure that there is no over allocation. But the problem with that is, after doing that you need to check whether the end date is changed or whether it is same as the old end date. There is a possibility that end date will slip when the resource is leveled by MS Project. And if the new end date is agreeable for the customer, it's okay. Otherwise, if the new end date is not agreeable with the customer, you need to again rework on the schedule and ensure that you can complete the project on the agreed end date. There is an automatic option in the MS Project. If you enable the automatic option of resource leveling in the MS Project, which is not the default, you need to manually enable that option. If you enable that option, what MS Project does is, as soon as you keep on adding new tasks and schedule the activities, it will automatically ensure that there is no over allocation of the resources. And once you keep on scheduling, you will be sometimes surprised if you enable this option. You will be surprised to see that you have decided to start an activity on a particular day and put the duration and sequence those activities, but as soon as you do that, you will find that once you complete that, you will find that the end date and the start date are changed automatically. This is done by the MS Project to avoid over allocation, because you have enabled automatic leveling option. So sometimes you will get confused. So recommended option is manual option. It is better to avoid automatic option and do the leveling manually. So resource leveling I already discussed in detail, and once you complete resource leveling, and if the end date is agreeable to the customer, you can baseline the schedule and start tracking the schedule. And there is an option to baseline the schedule in the MS Project and the Primavera. You need to baseline the schedule once it is reviewed and approved by all the stakeholders. And baseline is the current finalized schedule which will remain fixed, based on which you are going to compare the actual progress of your project. So the tracking of the project schedule is based on the baseline you set in the schedule. So after you baseline, you can start tracking the project in order to see whether there is a schedule slippage in the project. every week as you monitor the progress and status of the project, you look at there is another view called tracking Gantt chart view, which will show you whether there is a schedule slippage. So we'll look at how do we track the schedule once we finalize the schedule. So the basic objective or goal of tracking is to ensure that the project is completed on schedule within time, and to get visibility in the project execution so that corrective action can be taken to ensure successful completion of the project on schedule. So in order to start tracking, you will update the actual progress of each and every activity on a daily basis in the MS project schedule. So as soon as a project activity start, you will set the actual start date in the activity, and at the end of every day you can also set the progress percentage completion of each activity, how much percentage of activity is completed on a daily basis you can update. And when an activity is complete, you can set it as 100% and set the end date of the activity. So all this can happen on a daily basis, and we can use some tools to see whether there is any schedules. Another tool is variance analysis and value analysis, which is outside the scope of your syllabus. And when you monitor the progress of the project on a weekly basis, suppose you find that there is a schedule slippage in your project. So what are the options available for a project manager to control that schedule slippage? So there are various options available for the project manager. So this slide shows the list of options available for a project manager to minimize the deviation or avoid the deviation. The first option could be the change the task relationship, which is called fast tracking. So ideally you may be sequencing some of the activities sequentially one after the other. For example, coding can be started only after the design is complete. That's the ideal way of doing it. So the design and coding could be scheduled in a sequential way in the original ideal way. But if you find that there is a slippage in the project, you can try to make those activities parallel. Instead of waiting till completing the design, you will start the coding even if the design is not 100% complete. You will start coding of modules for which the design is already complete, and by the time you complete that module, then their design may be completed so that you can continue with further development. So instead of waiting till completion of design, if there is a schedule slippage, you can start the coding in advance without waiting for the design to complete 100%. That approach is called fast tracking. You are trying to fast track the coding in order to avoid the schedule slippage of the project. Second option could be add more resources. If you find that there is a slippage in one activity and the project end date, you can add more resources to advance the schedule or overcome this schedule slippage. That approach is normally called as crashing. Redistribute resources. The schedule slippage normally happens when there is a slippage in one of the activities on the critical path. If there is a slippage on the non-critical path, the project end date may not get slipped if the slippage is within the float available. So suppose you find there is a schedule slippage on one of the critical activities, and you find that the resource assigned for that activity is a less skilled resource or low skilled resource, whereas there is a highly skilled resource who is currently working on a non-critical activity. Then you can switch those resources. You ask the highly skilled resource to work on the critical activity, and you move this low skilled resource to the non-critical activity. So you can redistribute resources between activities in order to avoid schedule slippage. Use improved technology. And in order to advance the schedule, you may try to utilize technology, automate some of the activities so that the duration taken for that activity can be reduced. For example, you are planning to do the testing manually and you have assigned the duration based on the manual testing, but now you find that there is a schedule slippage. So try to see whether you can automate some of the testing so that the total duration for the testing can be reduced. So use technology, automation, etc. to reduce duration for the activities or improve the productivity of the team so that the duration taken for the activities can be reduced. Change contract scope. If nothing works, you negotiate with the customer and try to reduce the scope. That could be the last option. Change suppliers. So you may be dependent on a delivery from a supplier, and if the delivery from the supplier gets delayed, your project will also get slipped. And if you find that there is a slippage from the delivery from the supplier, one of the options could be the last option. Again, that could be the last option, because during the middle of the project, changing the suppliers may not be very easy. So if you find that there is a problem with the supplier during the beginning of the project, you can change that supplier to a more stable supplier. Renegotiate terms with the supplier. And another option, better option than changing the suppliers, is to change the contract with the suppliers or subcontractor. So you might have agreed for a fixed price contract, meaning you will reimburse, you will actually give the fixed price. You will decide a fixed price in the beginning of the contract and say, once you complete this activity, you will get this much money. So even if there is a slippage, he is going to get the full money, so he will not be motivated to deliver before time, deliver before time or deliver in advance. So you negotiate with the supplier and say, we are going to change this contract on a slightly. So instead of a fixed price contract, we are going to have a fixed price contract plus incentive fee, where you will get the fixed price plus a 2% extra in case you deliver the result for every 1 week advance delivery. So if you deliver for every 1 week of advance delivery, you will get 2% extra. Whereas also, if you delay the delivery by 1 week, there will be a penalty of 3%. So you will change the contract from a fixed price to fixed price plus incentive fee, where if the supplier deliver the product 1 week in advance, they will get 2% extra. Whereas if there is a delay of 1 week, they will lose 3%. So once you change this contract, renegotiate the terms with the supplier and change the contract to fixed price plus incentive fee, things will change automatically, immediately. So the supplier will do whatever possible to deliver in advance so that they can get extra money, and they will try to avoid the slippage so that they will not lose money. And use subcontractors. Suppose you find that there is a constraint on the resources, that's why the slippage is. So you don't have enough skilled resources for doing some activities, that results in the schedule slippage. You can change the plan to outsource some of the activities to subcontractors, so they can also start working parallelly along with you, and so the schedule slippage can be avoided. Use subcontractors. So these are the various options available for a project manager to control schedule deviation or schedule variance. So this is the view, the Gantt chart view, which we talked about. There are different sections in this Gantt chart view, which is indicated using these labels. You can look at those labels and find what is the different areas in this Gantt chart in the MS project. This is the MS project default view, Gantt chart view, and this slide indicates various areas in the Gantt chart view. Thank you. That's about scheduling and tracking as far as your syllabus is concerned. Thank you. We'll meet again with another module.